dark energy, the invisible hand, propelling the accelerated expansion of the entire universe, stands as the greatest unsolved mystery in modern astronomy. For most of human history, we thought the universe was either static or slowing down as gravity pulled all matter together. We believed that the stars, planets, and galaxies would one day slow their drift, maybe even collapse back into a single point. But in the late 1990s, a team of astronomers made a discovery that turned our entire understanding of the cosmos upside down. The universe is not just expanding, it is accelerating, and the force behind this mind-bending phenomenon is something we call dark energy, a mysterious, invisible power that makes up nearly 68% of the entire universe. We cannot see it, touch it, or detect it directly with any of our current instruments, yet it dominates the fate of everything that exists. Today, we're going to journey to the edge of known physics, unpack the history of cosmic expansion, decode the hard evidence for dark energy, and ask the biggest question of all: what is this invisible force that is tearing our universe apart? Long before we knew about dark energy, scientists were already debating the shape and motion of the universe. In the early 1900s, Albert Einstein developed his general theory of relativity, which redefined how we understand gravity, space, and time. At the time, Einstein and most other physicists believed the universe was static, unchanging, and eternal. To make his equations fit this static model, he added a fudge factor, called the cosmological constant, a repulsive force that counteracted gravity and kept the universe from collapsing. But just a few years later, astronomer Edwin Hubble made a revolutionary observation. Distant galaxies were redshifted, meaning they were moving away from Earth. The universe was not static at all. It was expanding. Einstein called his cosmological constant his biggest blunder and abandoned the idea, thinking it was a useless mistake. Little did he know that nearly a century later, this same constant would become the leading explanation for the most mysterious force in the cosmos. Hubble's discovery changed astronomy forever. It proved that the universe had a beginning, now known as the Big Bang, and that it had been growing larger for over 13.8 billion years. For decades after, Hubble scientists assumed that the expansion was slowing down. Gravity, the force that holds stars and galaxies together, should be pulling all matter inward, gradually breaking the universe's growth. This made perfect sense. If you throw a ball into the air, gravity pulls it back down. The universe should act the same way. But in 1998, two independent teams of astronomers set out to measure this slowdown by studying type Ia supernovae, the brightest and most consistent exploding stars in the universe. These supernovae act as standard candles, allowing astronomers to calculate exactly how far away a galaxy is and how fast it is moving. What they found shocked the entire scientific community. The farthest supernovae were dimmer than expected, meaning they were farther away than they should be if the universe was slowing down. The universe was not decelerating, it was speeding up. The expansion was accelerating, and there was only one explanation. An unknown, invisible force was pushing space itself apart. This force was named dark energy, and it quickly became the biggest puzzle in modern astrophysics. Let's break down what we know for sure. First, dark energy is everywhere. It does not clump together like stars or planets. It is evenly spread throughout every corner of space, from the empty void between galaxies to the space inside our own solar system. Second, it has a repulsive effect, the opposite of gravity. While gravity pulls matter together, dark energy pushes space apart. Third, it is incredibly powerful. It makes up roughly 68% of the total mass energy of the universe. To put that in perspective, all the ordinary matter, we can see stars, planets, trees, humans, every atom we know makes up just 5% of the universe. The other, 27%, is dark matter, another invisible substance that holds galaxies together. So, 95% of the universe is completely invisible to us, and dark energy is the dominant player. This staggering reality hit the scientific community like a tidal wave, forcing researchers to rethink every foundational idea they held about cosmic evolution, and sparking a global race to uncover its true nature with every tool and telescope at our disposal. Scientists have two leading theories to explain what dark energy might be. The first is Einstein's abandoned cosmological constant, now called the vacuum energy of space. This theory suggests that empty space is not truly empty. It has its own energy, and this energy creates a repulsive force that drives expansion. As space expands, more empty space is created, which means more dark energy, making the acceleration speed up over time. The second theory is called Quintessence, a dynamic, changing field that fills the universe and acts as a repulsive force. Unlike the cosmological constant, quintessence could weaken or strengthen over time, changing the fate of the universe. Right now, we have no way to prove which theory is correct, or if dark energy is something entirely different that we haven't even imagined yet. It could be a flaw in our understanding of gravity, or a new law of physics that only applies on cosmic scales. The discovery of dark energy also forces us to confront the future of our universe. If dark energy continues to push space apart at an accelerating rate, the universe will end in what scientists call the Big Freeze, or heat death. Trillions of years from now, all the stars will burn out, galaxies will drift so far apart that no light can reach one another, and the universe will become a cold, dark, empty void. Some physicists even theorize a more violent end, called the Big Rip, where dark energy grows stronger over time, tearing apart galaxies, stars, planets, and eventually even atoms themselves. But we won't know the true fate of the universe until we unlock the secrets of dark energy. NASA and leading space agencies around the world are now racing to study dark energy with cutting-edge telescopes and missions. The James Webb Space Telescope, the most powerful space telescope ever built, is peering deeper into the early universe than ever before, observing distant galaxies to measure how fast the universe has expanded over time. The Nancy Grace Roman Space Telescope, set to launch in the 2020s, is designed specifically to study dark energy, mapping millions of galaxies to unlock its secrets. These missions are not just looking at stars or planets, they are trying to answer the most fundamental question about our existence. Why is the universe behaving the way it is? What makes dark energy so profound is that it reminds us how little we truly know about the cosmos. For centuries, humans have looked up at the sky and thought we were uncovering all the universe's secrets. We mapped the planets, measured the stars, and understood the laws of gravity. But dark energy tells us that the majority of the universe is hidden from us, a silent, invisible force shaping every part of reality. It is a humbling reminder that the universe is far stranger, more mysterious, and more wonderful than we can ever imagine. We are just beginning to scratch the surface of this cosmic mystery, and every new observation brings us one step closer to understanding the invisible force that controls our universe destiny. As we wrap up this journey into the heart of dark energy, take a moment to look up at the night sky again. Think about the invisible power pushing every galaxy farther apart, the force that Einstein almost discovered, the mystery that drives modern astronomy. The universe is not just a collection of stars and planets, it is a story of discovery, of questions, and of the endless pursuit of knowledge. And dark energy is the biggest chapter in that story yet. Please like, comment, share, and subscribe to the channel